Hello, this is Mr. Huber. In this lesson, we're going to look at some more direct variation. A reminder, direct variation is a linear equation we can write y equals kx in that form where k is called the constant of variation. And remember that when we do that, if we divide both sides by x, right, and that cancels out, we'll be left with y over x equals k. That's how we can find the constant of variation for a direct variation. So if we look at this first example and we want to write a direct variation equation, we need to know what k is equal to in each of these situations. So for this first one, we'll have k equals y, which is 2, over x is negative 1. That's negative 2. So our equation here would be y equals negative 2x. That would be the equation that goes with that line. Then in the second example, let's have you try it. Pause the video. Try to come up with the equation for this graph. All right, now that you've had a chance to try it out, k is equal to y over x. Keep it as a fraction, and then write your equation y equals 5 over 4x. And that would be the equation for that graph right there. There's your equations. Again, you find the k value, and you plug those in for the y equals kx form to get your direct variation equation. Let's look at how we can use some direct variation in some applications. Okay? We've got this situation here with an aquarium, saltwater aquarium. We need to add salt to the water. So this is telling us that the amount of sea salt needed varies directly with the amount of gallons of water in the tank. So we have S for the numbers of tablespoons of sea salt, and W for the gallons of water in the tank. Okay, it says the pet shop owner recommends adding 100 tablespoons of sea salt to a 20-gallon tank. Write a direct variation equation that relates W and S. So what we want to be able to do here is to identify which of these is our Y and our X, if you will, and the Y equals KX. So the output, the dependent variable, the amount of sea salt that we add in depends on the size of the tank. So we want to be able to write an equation in the form S equals KW. Right? The S is our output, our dependent variable. The amount of tablespoons of sea salt depends on the number of gallons of water in the tank. So to find K then, we're going to do S over W, which in this particular problem, we have 100 tablespoons of sea salt recommended when there is a 20-gallon tank. That comes out to 5. 100 over 20 is 5. So we could write the equation S equals 5W. The amount of sea salt is equal to 5 times the gallons of water. 5 is the constant of variation here. Then we can answer the second part of this equation, which says how many tablespoons of salt should be added to a 30-gallon saltwater fish tank. So for this part, we want to know how many tablespoons of sea salt we need to add for a 30-gallon tank. So that'd be 150 tablespoons. Okay. And write the equation by finding that constant of variation. Identify your independent and dependent variables so you know which one's, the y, if you will, and which one's the x, our inputs and our outputs. Okay. Before we look at a couple other problems here, let's talk about another Billboard Top 100 trivia question. A little music break as well. What artist group has had the most #1 singles? Let's show a picture and see if that might help anybody out. There is the group The Beatles. Had the most at 20 #1 songs, including Hey Jude, which was their longest running #1 song, staying on top of the charts for 9 weeks. But 20 #1 hits for the Beatles. All right, now let's look at another direct variation situation here. We want to be able to determine here if this is a direct variation. The problems we've had up until now have said, y varies directly with x, or s varies directly with w, things like that. Now we want to be able to figure out if it's direct variation. If it is, we need to have a constant of variation. That means it needs to be the same k value all the way through the problem. So we could figure that out here by finding k equals y over x. Y over x, y over x, and y over x. And you could reduce these 2 over 4 to 1/2, 4 over 8 to 1/2. And it looks like, hey, I've got a constant of variation. K is equal to 1/2. But then you get to this last situation, and let's make that a little cleaner there. 6 over 16. That reduces to 3 over 8. Okay? These are equal, not equal there. So there's not a constant of variation. So this is not direct variation. In order to be direct variation, there has to be a constant of variation that is constant for the whole set of information for the problem. If we took out this part here, then we'd have a constant of variation of 1/2, and we could write a direct variation equation. But that's not the case here. We have to include all of the information and see if there's a constant of variation throughout all of it. Okay. Now if we look at another example here, problem, we've got this online music situation where we take a number of songs that are being downloaded and the cost it is in dollars. Okay. So we want to explain why C varies directly with S. So in order to do that, we want to find a k value, which is y over x. Okay? Y over x, or C over S, because that's our output, right? This is like our y and our x value. We change the variables, it's okay. And then we have 6.93 over 7. Okay? If you divide all these, like if you take 2.97 and divide it by 3, you get 0.99. 0.99 and 0.99. They all work out to 0.99, so they're all equal to each other. So that's how we know that C varies directly with S, because there is a constant of variation of 0.99. And then we're going to write a direct variation equation that relates S and C. So in order to do that, we can have the cost is equal to 0.99s. Okay? This means we're paying 99 cents for every song, essentially. The cost is equal to 0.99 cents times the number of songs. Right? So find if there's a constant of variation by doing your y over x, or again, depending if it's c over s or whatever the variables might be. And then you can use that to write the equation. And so we could figure out if we wanted to know how much it was going to cost. For 15 songs, we could plug a 15 for s, 0.99 times 15. Or for 8 songs, or any number of songs, we could plug in and figure out what that cost would be. So now you've seen some applications for direct variation. I'd like you to try the 5.2 Day 2 direct variation quiz. It's posted on Moodle. Good luck.